Right. Thank you for attending my session on LLM powered autonomous agent. Now, this is relatively a new topic which has kind of come up in last couple of weeks, and it offers a lot of promises when where it's where from a software architecture and design standpoint of view. Now, this is one thing which is going to change the way we write software. I'll talk to that in a minute, and let me first kind of go through in terms of what an LLM autonomous agent. At the heart of it, this has a LLM, and it can understand the environment and it can act accordingly to achieve the goals. It uses LLM as a core component. It can communicate with humans and other agents, specifically in terms of like a reinforcement learning and learn from feedback as well. I won't invest too much time. I'll straight away kind of walk into what the system overview looks like. Now, in this case, the LLM kind of functions as the brain of the agent, and there are other components. For example, there is a task decomposition or planning component whereby you break down the task into smaller, manageable tasks. Or sub goals, and eventually kind of go do those tasks at a lot more easier level. Obviously, there is going to be some amount of reflection and refinement. So we are expecting most of these agents to do some level of self-criticism, self-reflection. Obviously, there are frameworks to do this kind of things, and it's like more kind of going over the past actions and learn from mistakes. So if you were writing an agent specifically which is dealing with stock market predictions and where to invest and where not to invest, and apparently in some places obviously we do end up making losses, and this is where the agent can actually go through the entire series of prices and then decide in terms of what was wrong and what could have been done differently. Now, typically when you kind of coming down to tasks, a task generally can be very simple task in terms of one or two lines of question, or in terms of what has to be done. But sometimes the task generally ends up being a lot more complicated. Now, in situations like that, you are going to use something to kind of break it down. So, as a human would do that, they would break down the task, using some kind of chain of thoughts, and then eventually dig deeper into each task. That's where the tree of thoughts really come in terms of providing the right information to kind of go do the job. Self-reflection is more to improve iteratively by refining past action decision and correcting previous mistakes. Chain of hindsight, that's an important framework which is going to be of use. In addition to this, the agent also has a short term and a long term memory. The short term generally ends up being a Redis cache or something of that nature. Long term memory is again required. There are a lot of places where we can do plenty of stuff, and now the tools is the third party APIs, external information, which improve iteratively by refining past action decisions and correcting previous mistakes. So there are tools like MRKL, Talem, Hugging Face, which eventually can integrate from, especially from integration standpoint of view. Now on the left hand side, we're seeing a simple agent which basically has calendaring, calculator, code interpreter, search, and I could go ahead and make my own agent which is doing my day-to-day activity in terms of trying to do these things a lot more easier. So that helps me kind of do my task on a day-to-day basis and a lot more easier. Now, some important terms which are going to come into it. So basically, from a component standpoint of view, chain of thoughts is breaking down the large task into smaller subtasks, prompting techniques instruct to think step by step. Now, if you've been using GPT-3 or 4, you obviously would be aware about different prompting techniques, and chain of thoughts is one of the prompting techniques which basically breaks down a larger problem into smaller tasks to basically solve the problem. Tree of thoughts extends the COT, breaks down the problem statement into steps. For each steps generate these thoughts. By LLM, simple prompting steps to XYZ. This is just an example that we kind of talked about. Write a story, outline, and write a novel and human inputs. Now, the third place which is really interesting is basically from a task standpoint. Typically, when you're getting into areas where GPT-3 or LLMs can't handle, in those situations, you would obviously go ahead with something which has cut out to do. The symbolic planners really kind of plays into this. So LLM plus planners typically ends up using breaking down the problem statement into more manageable parts. So they have a planner which kind of gives you the solution, and then eventually also gives you the stop steps to solve the problem. Typically, where we get into areas from a number or a match standpoint of view, LLM plus planners work out to be an absolutely great option. In addition to that, you also need to think in terms of self-reflection. And when it comes to self-reflection, there are frameworks like React, which integrates with the reasoning and acting. And this is just to kind of give a view in terms of what are the important terms and concepts which actually play into that. Now, I would like to kind of go deeper in terms of what are the specific practical use cases from an autonomous agent standpoint of view that can come and help in terms of customer support bots, personal assistant, content generation, programming assistant, research assistants, gaming. Now, furthermore, there are some more also when it comes to finance, BFSI, the financial advisory, build agent that can answer questions about the financial products, market trends, and generic financial advice based on user queries, healthcare, the virtual health assistants, advisors, e-learning, e-commerce, real-time language translations. In addition to that, we also see entertainment, recruitment, and mental well-being and home automation. So in short, we see the LLM autonomous agents can actually fit into multiple places. I will be taking a separate session which talks about what the LLM autonomous agent architecture is really looking like, to kind of going a little deeper into that. But this session is only a level 100 session, which kind of gives you an overview of autonomous agents and where are the specific use cases. The case study basically, if the one which has already been published is regarding a scientific drug discovery. ChemCrow is a domain-specific example for LLM agent which is augmented with 13 expert design tools to accomplish the task. This is the tools and integration piece that helps in terms of organic synthesis, drug discovery, and material design. The workflow for this was implemented in LangChain and combines the chain of thought reasoning with the tools relevant to the task. LLM is provided a list of tool names, description, utility, and the details from an expected input-output standpoint, and then instructed the answer to a user to give in prompt using the tools when necessary. So you see, LLM plays a role trying to orchestrating all of this together. An interesting observation is the LLM-based evaluation concluded that GPT-4 and ChemCrow perform nearly equivalent to human evaluation, with experts oriented towards completion and chemical correctness of the solution. So just one example we've seen where LLM autonomous agents, there are a zillion examples where it can really fit in. I like to quickly go in from a real life demo standpoint of view. We are in the basically in from a software development standpoint of view. As a developer, you obviously want an autonomous agent which is going to kind of write code, write test cases, and eventually push the tested code to a repo of your choice. So let's quickly walk into the demo. So in this case, I'm going to run the demo. So I have the autonomous agent. So here I'm asking, what do you really want to do? I'm going to go ahead and say, okay, I would like to do coding. I said, okay, in this case, write code which reads two pandas, data frame, employee, and let's say customer, sort them and show me the results. Also populate this with some data. So this is what I'm kind of giving. Let's see. So this is the coder piece. I'll talk to that in a minute in terms of what tool I have used to basically bring all of that together. But this generally is going to use the tools to kind of build out the specific code. So in this case, it ran into issues with an error. So here probably it's correcting the error as well simultaneously, which is a good thing. Here it's kind of hitting pandas, because obviously pandas probably is not there. It's now basically going ahead and creating data frames for employee and customer with data. So you can see it's eventually kind of getting there. And once the data is there, then it's going to go ahead and basically write the code. So here this is where it's kind of populating the data frame, and it's just showing the different data frames that we have, the employee and the customer point of view. And then the next step is going to go ahead and basically sort that on specific age and just show it to me. So it's a very simple thing, and then eventually once it's done, it's going to come back and ask me in terms of what would I want to do next. So this is just a very simple autonomous agent. Obviously the pieces of code where we actually going to go ahead and write the test cases and checking into the repo has not been done, but I'll walk you through the code in a minute. So this kind of completes the task. So now kind of let me walk through the code. So the code is a fairly simple piece of code where I just have the method. So in this case, we end up using the code interpreter, the OpenAI code interpreter, which is supposed to generate the code. So in this case, you can see the AI developer, which is going to go ahead and write the code. So if I actually go down to the definition, it uses this library and it does this piece in terms of writing this code. So very simple. I've just kind of used tools along with all of that. So in this case, I may end up using tools for the test cases piece as well, and similarly for run tests, and obviously from push to GitHub. And where I'm just really going is that LLM does a lot of things differently in terms of what we were supposed to write code and eventually kind of go ahead and do. But then it kind of helps in terms of automation, and autonomous agent really plays a major role. Now with that, I will kind of stop my presentation.